Hi everyone, this is Ms. Lesensky, and this is for the Enzyme Lab for NGSS Biology. We're going to walk you through how to use Desmos to graph your data for pH, and then you'll be going through the same process when you collect your own data for the Enzyme Lab. So the first thing we need to do is label our axes. So we've got this wrench up in the top right corner here. We're going to click on it and change our x-axis label to what we want to put on our x-axis. So the usual rule is that our manipulated variable, otherwise known as the independent variable, goes on our x-axis. So that's what we're going to do here. In this experiment, we collected data on how pH affects the reaction rate of this catalase enzyme. We measured reaction rate by measuring the height of the bubbles. So in this case, our manipulated variable is pH. We always want to include units, but pH is on a scale that doesn't really have units. So I'm just going to say pH. On our y-axis, we measured the height of the bubbles. And we know that the higher those bubbles, the more that catalase reaction was happening to make oxygen gas. So we measured the height of bubbles in centimeters. So label your axes, pause the video if you need. Now we're going to name our variables. So this is just a Desmos thing. We just need to come up with a letter that we want to use for the variables on our x and y axes. So you can make it whatever you want, as long as you make sure that this variable here matches what's in your data table below. So on the x-axis we had pH, so I'm going to make it a P. It does need to be a subscript 1, but Desmos knows that. So if you just type P1, it will automatically make that subscript. So make sure that matches. Our x-axis is going to go first in our data table, so this is going to be P1 as well. Then on our y-axis, we have the height of bubbles. Let's make it an H for height. So I'm typing H1. And down here, I also need to make that H1. All right. Now, we're going to plot our data. So looking at the data that I collected here, I have 10 different data points. So I'm going to put in all 10 data points. It doesn't matter what order I put these in, but what does matter is that the pH goes next to its corresponding bubble height. For example, in this first test tube A, the pH was 3 and the height of bubbles was 0.4. Those two need to go together. So I'm going to say 3 for pH, 0.4 for height, and so on. So go ahead and put in all your data. It's all right if you have slightly different numbers from mine, put in whatever you recorded. Here's what mine looks like. So pause the video and do that. Now we've got our data in there. We're going to try and determine our line of best fit. So to me, already I'm looking at this and I don't see a linear pattern. It looks like it goes up and then back down. I think we're looking for a curve here. But let's look at the line of best fit. We have a bunch of equations already programmed in here for you. I recognize this y equals b as the line for, or as a horizontal pattern. Back when you learned these in patterns physics. So you can turn these on so you can see all these different lines. You can move these sliders to see how that changes the lines. So take a minute just to turn on the lines and mess with them and try and decide which line of best fit matches our data best. And I found that this curve, the Gaussian curve, fits our data best. So we have 4 different variables inside this equation, A, B, C, and D. So I would start by just making them not 0 so you can see this curve. So if you haven't selected the Gaussian curve, select that and deselect all the other ones. Don't press the X's because that gets rid of it permanently. If you already did for one you don't need, it's not a big deal, but in the future don't press the X's. It's much easier to just toggle this on and off this way. So now take a few minutes to mess with these 4 variables, A, B, C, and D. Try and figure out what they do to this line and try and get this to match your data. And we'll do the same. To adjust this to match my data. I think it needs to be a little fatter. Remember, you're kind of trying to average all of these data points here. So ideally, I'm looking at the dots and trying to get about the same amount on both sides of the line, above and below, so that it can be as close as, get this line as close as we can to all these different data points. All right, I don't know, something like that looks pretty good. So adjust your line to be as close to those data points as you can. Now let's look at error bars. So should have already decided on an uncertainty for pH and for the height of the bubbles. So let's think about what makes sense here. Your uncertainty may be slightly different from mine. It shouldn't be wildly different from mine, but as long as you can explain why you chose the uncertainty that you chose and it makes sense, that's what's most important. So you may remember that there is one way of calculating uncertainty. We call it the measured uncertainty. Is that true? We call it calculated uncertainty. Sorry, we keep switching what we want to call it. I believe we've called it calculated uncertainty in the past versus experimental uncertainty. The difference between those ways of calculating uncertainty is that the calculated uncertainty, you're measuring the same thing a bunch of times and you're figuring out your range and dividing that by 2. So if we had taken the one test tube and had a few different people measured it a bunch of different times, then we could take that, get the range and divide it by 2 to get uncertainty. But since we don't have enough, we didn't measure it enough times to really get a good range or a good uncertainty that way. We're going to do what we call the experimental uncertainty, which is just using logic, thinking about what uncertainty means and thinking about the way that you collected data, how far off you think you might be from the actual correct answer. So that's what I'm going to do. I'm thinking about my horizontal uncertainty. So as I move this, I can change the uncertainty. For pH, we were looking at this video and we were trying to match the colors. I couldn't even read the numbers on there, but I think I figured out what they were. And it was pretty hard to match that color exactly. So I feel like if I said it was a 3, it's possible it could have been a 2 or a 4. I feel like I might have been off by up to an entire pH, one on the pH scale. So I'm going to make my horizontal uncertainty for pH be 1, meaning when I recorded this as 12, I'm acknowledging the true value of that pH. It might have been anywhere between 11 and 13, and I recorded it as 12. So same thing for height of bubbles. In an ideal situation, we will take half of the smallest increment on that measuring tool. So we could see millimeters on that ruler. So I would say half of a millimeter. However, the bubble line was not flat. I was reading it off a video. It was hard. It was hard to measure. So I'm going to say it's a little bit more, I think about 0.3. I measured very carefully. I think about 0.3 might be as much as I was off by. So now we have these data points, and for each of these, we're acknowledging that the true value of this measurement is somewhere within this box. So I'm noticing the fact that most of these data points go through our line. That's pretty good. Not all of them do, so that we definitely don't have perfect data here, and that's okay. Okay, and then just don't mess with this bottom part, not for editing. So now you are going to insert this image of your graph into your document. So you may have done this last year, but to remind you, you're going to share your graph. You're going to export image in order to download it. And then you can take that and put it into your document.